using ideas from the FDTD method, this is what I came up with for the outline for our code. First, we'd want to set the parameters like delta t, what that should be equal to, delta z, and so forth. Declare our variables like voltage and current that we want to use to store the values, and solve for our coefficients. And then we're going to need some sort of a loop where we iterate through time, and we're using time step number as n. So we'd have 1 to n max. We'd iterate through time. This is going to create a loop. And in that loop, we're going to want to implement a source. There would have to be some sort of way to create the voltage and current waves that get them started. And then we'd have to solve for the future current values at each half time step, n plus a half, using one of the telegrapher equations, update equations that we just derived. And then another half step later, we can solve for the future voltages, n plus 1. And that would probably be, we could, maybe store some output and do some other things, but that's generally what we would do. And then afterwards we would analyze. I guess we'd have to record and analyze, and probably it might include plotting after the simulation. We'd have to look at the results. So in lab next week, you'll be building this code and running a few scenarios so that we can get an idea of how well the code works and whether it looks like it'll be useful for our SSTDR in investigation and proposal that we want to write. So this will help us to plan out how to write our proposal, to obtain funding, and create our proof of concept demonstration.